Hello everyone, and welcome to my presentation on visual design. So before I start, I would like to quickly introduce myself. I am Rutuja. So I am originally from India, but from 2017, I've been living and working in Germany. And currently I work as a consultant at Accenture, helping the client with all the topics related to data and design. And our end user focus is creating user-centric dashboards. And that's what all is going to be the focus for my visualization design today. And when I'm not working, you will find myself wandering in the nature, traveling, and I also volunteer as a teacher at a local NGO. So let's start with my talk on visual design. Before I start, I have something for you. How many of you can identify what is this road sign for? If you can identify, you can just have a raise of hands. Oh, I can see a lot of more people. And there's also a hint, like if you have a road sign before that road, it goes into something like that. And why I'm talking this about at this point is because, so 9 out of 10 companies, they are investing in data, but the return on their investment is not traceable or it is not findable. And they are getting stuck in what is known as a data dead end, or it is also called as cul-de-sac. And my session today on visual design will help you to focus so that your projects are not getting stuck in what is known as data dead end, and you don't know from there where to go because you have the data, you have the insights, but you still cannot make any decisions on that. This is pretty much the agenda for today. So we will start by understanding what makes a good viz design. How do you select different charts for your different data visualization projects? And I also have some science behind you, because design is not only about making things beautiful, it is also about telling what is the science behind it, which leads to these design decisions. And at the end, we have closing and some time for Q&A. So let's start with first one. Before that, it is very crucial to understand that what is visual design. So visual design, it focuses mainly on the aesthetics of the product. And our product here is our dashboard. So whatever the dashboard we are developing, that is our end product. And how does it try to improve these aesthetics? Is by strategically combining and placing its different elements. Which elements, you may ask? So elements are nothing but images, color, typography, layout, and also your space, like where do you want these dashboards to be placed? Is it in a 2D space or is it in a 3D space? And now let's understand what makes a good viz design. So before I show you the next visual, I would like to excuse myself because it's something like this. It is a visualization, and at this moment, I would like you to pause yourself and find out what do you think is good in this visualization, what do you think is bad in this visualization, because it's very important to understand before we make a visualization, what is the bad and the good aspects. Can anybody from the audience tell me if they have found anything good about it? A raise of hands if you have found anything good. OK, I have an optimistic audience. Can you loudly say what did you find good in this visualization?
It's attention grabbing.
OK, attention grabbing. Is it in a good way or is it in a bad way? Attention grabbing. OK. Leave it to the thinking of the audience, whether in a good or a bad way. Anybody else? Anything good about it? Yes? OK, you can see numbers. We have 2 optimistic audience among the room full. It is actually, let me give you a hint, it is actually about the coral reef distribution all over the country. So it tells you about how the coral reefs are distributed. And it is published in one of the scientific journals. So if you Google this image, it is there on the internet. But we saw that in so many people, we had just 2 raise of hand having good aspects. I know you all have bad aspects, so let me point it to you. The bad aspects are that, so when I told you, it just, as we saw, attention grabbing. So from my side, it will be like it pops in your eyes. It just goes in your eyes because of the choice of the different colors. And at some point, the developer was finished with this color palette. He started mixing patterns in it. So mixing of colors and mixing of patterns is a big no. You should avoid at any cost. After that, you see there are so many labels, so it is very difficult for the human eye to map such labels to the different visualization, different colors. So using too many labels should be also avoided. Then you see there is a map, and then on the top of the map, there is a pie chart. So this combination of a pie chart on a map should be also avoided at any cost. But if the map was like a high-level overview in which the user maybe clicked on Singapore, and at the end, he had some statistics about the Singapore, like what is the distribution in that particular region, then the map would have served a purpose. But here, there is no purpose. It is just like a background image. So this harmony, or this combination, they just do not harmonize with each other. And that is why this visualization becomes an example of bad visualization at the end. But then, we also have different visualizations all over the internet, which when we look at the first point, we are like, wow, how this developer did this visualization. But then if you carefully examine it, you remove your visual design lens, you actually see what are the problems. So in the first one, you can see there is unnecessary use of 3D. So the bars are hidden, it distorts the reality. Then you also have this beautiful map, but to understand its different colors, you have to understand a different map, which is mapping the main map. So this is such an information overload. Then you also have some visualizations which do not have data labels in them, or you have a pie chart with too many categories. And such make examples of cognitive overload or vagueness in your visualization, even though they are aesthetically beautiful. So now you may ask me, then what is a good visualization? So a good visualization is something that equates to data understanding. It should have 4 aspects. So it should be showing the relevant insight in your data. It should be very easy to understand. It should be clearly presented, and it should be very, very engaging to look at. And if you start with a visualization and it meets at least one of these 4 criteria, then you are ready to move forward. Otherwise, you have to discard it, and then you have to start from all over again. Next is a very important task, that why do you have to establish a purpose? Because before you start anything, you require a purpose. And there are ways in which you can establish a purpose to your visualization, which will add like a meaningful context to it. And the first starting is by putting together a brief. And what does putting together a brief means? It means answering the 3 W questions. So first of all, why are you building this viz in the first place? What is your intention? Second is, who are you building this viz for? Like, who are your end users? Who are your stakeholders? And third one is that what do you want your end users to think, feel, and do after they have seen your visualization? So for example, you have something for product analysis. What do you want your users to think? What do you want your users to feel? And do you want your users to take specific actions when you have seen the visualization? And once you have put together these 3 W questions, it's time to start with the next part, which is nothing but sketching. So what is sketching? Sketching is nothing but iterating on your prototype. So you have to, first of all, when you have put together a brief, you need to start together by sketching it. So traditionally, it is done by pen and paper. But I would say that when you work in a very collaborative environment, I would use something called as whiteboarding tools or also prototyping tools. And the one which I use is Figma. So if you see there, these are like wireframes of the dashboards. You can create like basic sketches in Figma. And also, you can create very detailed prototypes, which you can show to your end users. And this sketching should be very iterative. Like, you sketch it, you show to your end users, you collect some feedback, and then again, you iterate on your sketch. And then once your sketch is delivering the right message, you can start prototyping it. You can make like a very detailed view in a design tool. And once your prototype also delivers the right message, only then you need to start building it in your tool of choice. Otherwise, you need to reiterate the process once again. Next, we will go that how do you select different charts for your visualization? Because there are so many options available, and we need to find out what is that serves our purpose. First is something you need to create is like, you need to consider what is your precision. So like how precise you want your charts to be. Do you want them to become most accurate? Like, do you want it to be playing with position, length, or angle? Or do you want it to be very least accurate, where you have something called as area or color, or you also play with some color intensity? And once you have decided on your precision, it is now time to map it to the different chart types. So what does it mean for chart types is that, so if you want to have most accurate, it means that you want to show something position and length. You have to go something with charts which encode the information, like a line chart or the bar chart. But if you're looking something on a very least accurate side, like a high-level overview, you need to go with something called as visual appeal, which show, for example, the maps or the tree maps or even the bubble charts. And this comes with practice because you need to develop something called as a visual vocabulary. And what is a visual vocabulary is that, for example, the main aim is to show correlation, then immediately a scatter plot should come to your mind. You should not think of a map. And the vice versa, for example, if you want to show some spatial analysis, immediately a map should come to your mind and not a scatter plot. So this saves your development times and efforts because you do not sit there thinking, okay, which chart should I choose for my purpose? And once you have this visual vocabulary, you think and act very faster, and that saves your time and efforts for the project. And next, we will go to what is called as design science, because people have this stereotypical misconception that design is only about making things beautiful. But there is a whole lot of science that is behind these design principles. And for that, I have something called as the Gestalt principles of visual perception. A previous speaker gave a few glimpses into it. I would like to go further deep down. So Gestalt means it's also called as a unified or as a whole. It was invented by the Gestalt school of psychology to just have a study on how humans perceive information all over the world. And these principles are very helpful to create dashboards because these are the reasons why some of the data visualization strategies they pass and some of them they do not perform better. And to explain this, I have a dashboard. And in this dashboard, I have 6 principles which can be typically implemented to your data visualization projects. So let's go through this dashboard one by one, starting with called as proximity. So proximity is nothing but grouping together. So if you see this image, you have these circles, and due to their affinity or due to their placement, you see that there are 3 groups. You don't think about it too much. When you have a glance, you see that, okay, there are 3 groups in this visualization. And what does this mean for your data visualizations or dashboard designs? Is that, for example, you have 2 KPIs. You have a profit KPI, you have a sales KPI. So do not scatter your information about these KPIs all over the dashboard. So group them together at one place in which you form like 2 groups, maybe one for profit and one for KPI. It creates like a very high-level, good overview of the dashboard. It is very easy and fast for the end users to grasp. And that's where, when you keep this related information together, you are deploying the principle of proximity. Next one is similarity. So you have seen the image was same as the previous one, but here I have something which I'm adding to much context. So I have a color. And in that color, you see now there are 3 groups. But for example, because of this gray color and this black color, you see that, okay, there is some relation between these 3 groups. So they are not distinct from each other. And that is what is similarity. It establishes like a natural association. And this, when you implement in your chart types, you see that you can use color, shapes, or you can use size in your visualizations. So here is a visualization which shows like an average SAT scores for different colleges. And then you have the College of Business, Education, and then Communication. So if you see I did not use any color or if I did not use any shape, you would have seen that there are only 3 types of groups which are differentiating the different colleges. But at the end, when you see the square group of communication, there is one circle which denotes the education one. And because of this shape, you know that, okay, it is not belonging to the College of Communication, but it is belonging to the College of Education. So there are 3 groups, but due to this proximity or due to this affinity, you see that there is some relation between these 3 groups. And it also helps to focus the user's attention to specific data points which we want to show. And it also eliminates the additional elements, like you don't have to put any borders around these data points to just show that they are similar to each other. So use of color, shape, and size helps you in adding a natural association in your views. Next one is something called as enclosure. So if you see there are data points, and then if you have like a border around few of the data points, you think that, okay, these are the points which are related to each other. And when you see what to implement in your dashboard, you can use something called as a background shading. And you have seen that in some of visualizations where you have the actual values and you have the forecast values. So the forecast values are always shaded together. This enclosure principle, it creates like a visual border. So this image or this chart shows like the average median temperature distribution. And some of the data points have a light background shading. So you don't have to do it very dark. You can implement a light background shading. It shows that these points belong to the relative average. Because of the shading, you can see that there is a distinction. So it is a visual distinction that there are some points belonging to average and some points are some others from the data set. And to separate or easily differentiate it, this enclosure principle is very helpful. After that, we have something called as closure. So when you look at this image, what do you see here? What do you see when you look at this image? Can anybody raise your hands? What is the shape, or what do you see? You see square, okay. Some others? 2 squares? Okay. Okay, we have a lot of creative minds here. Anybody else? What do you see when you see this image? Yes? Okay, open rectangle and closed square. Okay. I have a lot of answers from this audience. I would, on average, so people would assume it is like a rectangle. But why do we see that? It can be also like dotted lines. It does not have to be a shape. It is just dotted lines put some randomly together. But since our mind is like used to fill in the gaps, we see that, okay, maybe it is a square or it is a rectangle. And that's what is called as closure principle. And the closure principle, it helps you to eliminate your clutter on the dashboard. So there are some visualization tools which add like default grid lines, they add default borders or axes, and you don't require them. At the first time you will think, okay, that visualization tool has put it, must be important. But the closure principle says that you don't require this clutter on the dashboard. So there is a visualization, so I don't have any grid lines, I don't have any unnecessary borders. But apart from this, you see that it is very well entity on its own. It does not have to be removed, or it does not have to have any additive information. It is very well or focusing on its own. So this closure principle tells you to focus more on your data and make your data stand out instead of all the other elements around it. Next, we will move to what is called as continuity. So continuity goes one step further of the closure. And in this image, if you see that there are 2 shapes, so there is a rectangle and there is a triangle. And if I take these 2 shapes apart, many of people will say that it will be one rectangle and one triangle. But on the other hand, it can also be like a triangle and an incomplete rectangle because the triangle was overlapping it. But we usually feel that, okay, these 2 objects are on their own complete. And that's what continuity tells. So continuity is something that filling in the gaps. Also, in the context of visualization, it is the use of white space. So what is the use of white space? So it is the same chart, similar type, which I showed before, but here what I have done, I have removed the vertical y-axis. And even though I have removed the vertical y-axis, due to this efficient white space, you do not see the difference. You see that, okay, all the bars are aligned together as if there is an imaginary axis. So this consistent white space is something that can be deployed in your dashboards. I like to call white space as the oxygen which a dashboard needs to breathe. So do not overload with everything. Use consistent white space so that your visualizations stand out. It is focused more on data. And now coming to the last principle, which is called as connection. In the image, you can see there is a circle and there is a triangle. So we already have the similarity principle where we are employing the shapes. But what if we want to show something more further? There is something more strong connection. And that we can show this association with this principle of connection. And the chart types, so you can use like lines to connect the data points. So imagine in this chart, so these are the two, Amazon and Apple, which shows about the annual return. If I did not have this line between the data points, you would just say that there are two distinct groups, but they don't have any trends between them. But due to this line, we see that, okay, there is a rise or the fall in the annual returns between these companies. So indicating a strong association can be done with this principle of connection, which takes you one step further than similarity. And also, you can play with the properties like thickness or darkness so that you state or verify what is the degree of the association. Maybe it is a strong or less. So this were pretty much the 6 principles which can be deployed in your dashboard visualizations to make it much more effective. And next point is something that we need to talk about, because when you talk about design, you need to talk about the topic of color. So colors should be used very, very sparingly. So do not overuse colors. Use always like a meaningful or a consistent color palette. Go towards some warmer colors or softer colors instead of the very dark ones. And do not do like this. Do not make a cloud of colors on your dashboard. Also, gray is a very, very popular color. So it is an underestimated one. But this is one Tableau workbook or Tableau dashboard that gone to win the IronVis championship, and you can see that everything is in gray. So gray is such a powerful color to make your data stand out. Also, if you see this side, gray is used like as a background lines to focus the more temperature line in black more. So gray can be also used as a color of focus. And once you have used colors, it's not important only that. You need to make it colorblind friendly. So you need to make dashboards which are accessible, it should be inclusive, and can be used by all. And having colorblind friendly, it has some different options. So you can start by using colorblind friendly palettes. So for example, tools like Tableau, they have inbuilt color palettes which are colorblind friendly. You can start from there. You can also start using icons or labels as to distinguish the data. Do not use only color to distinguish your elements so that people are left out. And third one is you can use something called as a colorblind simulator. So here is an example of a colorblind simulator called as Coblis, which is available on the internet. And you can see how a normal person sees your color palette and how a person with green weak color blindness sees your color palette. So before using your color palettes, you can also test them into a colorblind simulator. And that brings to me pretty much end of my talk. And I would like to just summarize, like, why is this important? Why am I talking to you on this stage? It's important because if you have visual design, you create like a data storyline, it is very important for data storytelling. Your visualizations, they will act like a campfire, and around which your users or your stakeholders, they can collect or they can gather to tell stories from your data. And that's what sums up the importance of visual design. And next, I have, as a closing part, because design is such a big topic, I have some recommended books for you in which you can start your journey. So today, I just scratched on the surface. But once you want to start this journey of design, you can start with this recommended books of choice. And yes, as we all work in data, we know that what cannot be measured cannot be improved. So I would like to improve my session. And I would encourage you to please scan this QR code and provide me some feedback about what did you enjoy, what did you like about the session, and what do you want to see more. So yeah, thank you, and I open the floor to questions.
Thank you very much, Rutuja. Thank you very much. All right, questions?
Yes.
A question over there.
AI is now. Do I need it? So AI is here pretty much in focus in the entire conference, and I'm wondering. I've heard some lessons a couple of decades ago, and I see that people are constantly making mistakes. Do you perceive that there are some AI tools or some tools that can help us all to early detect the issues in a bad design? That we broke some of these things that you mentioned here. Is there hope for us who don't know these things upfront?
So if you have heard today's Casey's keynote talk, so she also mentioned the fact that people don't know about the theory, they just try and use the tools, and maybe they hit somewhere a jackpot and everything works out. So for me, I would say there are tools available on the internet. So for example, there are tools for eye tracking. How do you track on your dashboard? But the main starts by educating your team. So it would be nice that if you have some sessions for your teams in which the team is upskilled on this topic. So when they start doing their charts, they are doing it right from the first point. They do not have to use any tools at the end. And you are saving your time and efforts because you don't require tools at the end, you're doing it from the start. So educating the team on good visual design principles, it is very important, and there is a lot of information available everywhere. That would be the starting point. Of course, AI tools, like I have also seen some visual design chatbots in which you can just type and they can give you some suggestions on your chart. But knowing the theory always goes a long way, then you can save your time and efforts after that.
Thank you.
Thank you. Any more questions? All right. Then, Rutuja, I would like to thank you very much on behalf of the organizing team.
Thank you.
That's a certificate of appreciation.
Thank you.
Thank you very much.
Thank you.
And now we will have